Section 1.6. Section 1.6 objectives. Here's what we're talking about today. Solving polynomial equations by factoring. Now, you remember 1.5 we talked about quadratics, just quadratics, okay? But this goes into more polynomials, so like grouping, factoring by grouping, things like that. Factoring quadratic-like equations, and you'll see what that means in just a second, okay? Number 2, solve radical equations. Number 3, solve equations with rational exponents. Number 4, solve equations that are quadratic in form, like I mentioned up there earlier. Solve equations involving absolute value, and then solve problems modeled by equations. Okay? So in other words, word problems about all this stuff. Does that make sense? You ready? Okay. I'll go back to it in just a minute. Solving polynomial equations by factoring is our first objective. Okay. Like I said earlier, a lot of this stuff is stuff we talked about on last time we met. But this really involves more GCF, factoring out the greatest common factor. If you have 2x to the 5th plus 10x to the 4th equals 0, for instance, how would I solve that? That's not something I can really quote-unquote factor like we do the AC method or something, grouping or something like that, because there's only 2 terms. So what we want to look first is there anything common? Are both of these 2 terms divisible by anything that's the same? What's the greatest common factor? 2 for sure. X to the 4th, right? 2x to the 4th is the greatest common factor between these 2 terms. When you factor out a 2x to the 4th from this first term, what are you left with? X. 2x to the 4th factor out of the second term, what are you left with? 5. Right? Okay? So remember our property that we talked about last time, the zero products principle? You remember that? If 2 things are multiplied together and they equal 0, what has to be true about at least one of them? It has to be 0. So we said each one of these factors equal to 0. Whoops. Well, if 2x to the 4th equals 0, x is just 0, right? I mean, we could divide by 2 on both sides. 0 divided by 2 is just 0. X to the 4th is 0, so x is 0. Okay? Here we subtract 5 on both sides, so x equals negative 5. Any questions about that? So that is solving polynomial equations by factoring. That's just one example of it, okay? Factoring by grouping, you guys are really good at. Do I need to show you an example of factoring by grouping? Bring it back? Run it back. Okay. Let me find one real quick. Okay, well, I'll just make one up real fast. X to the 3rd plus x squared plus 5x plus 5 equals 0. If I'm solving by grouping, that means I'm grouping things together. So in this case, I'm grouping these first 2 terms together. What's the greatest common factor between those 2 terms? X squared. What's left if I factor out an x squared from just those 2 terms? X plus 1, right? Now group these 2 terms. What's common in those 2 terms? 5. What's left when I divide out a 5 from each term? X plus 1. Now, do they both have a common factor? What is it? X plus 1. If I factor out an x plus 1 from each term, what's left here? X squared. What's left here? Plus 5. Take each of those factors and set each of those equal to 0. So obviously subtract 1 from both sides. This will take us into what we kind of talked about last time, right? If I subtract 5 from both sides, I get x squared equals negative 5. If I square root both sides to solve for x, what do I get as my answer? Well, I'm going to get plus or minus first of all. What's the square root of negative? Very good. I square root of 5. So you okay with that so far? The next thing on our objectives is solve radical equations. Solving radical equations implies that we have an equation with a radical in it. Do you remember what a radical is? Root sign. 2x minus 1 plus 2 equals x. If it's a root sign, I'm glad you said root sign and not square root sign, because it may or may not be a square root sign. It could be a cube root or a fourth root or something like that. In this example, it is a square root. Okay. Remember the first thing to do when I'm solving a radical equation is I've got to isolate the radical. Okay. That means I need to subtract 2 from both sides to isolate the radical. 2x minus 1 equals x minus 2. So how do I get the radical to go away? Square root. No, I said the wrong thing. Square it like you said. Okay? If I square this side and I square this side, what happens on the left-hand side of the equation? So it's just 2x minus 1. What happens on the right-hand side of the equation? Oh, I multiply x minus 2 times x minus 2? Oh, so like this? So you're telling me I'm not just going to get x squared minus 4? Oh, I'm so glad. You made me so happy today. Distribute x squared minus 2x minus 2x plus 4. X squared minus 4x plus 4. If all you do is square both of them, you're going to miss out on this middle term, and you will get it wrong every time. Unless you make some other error and somehow magically end up with the right answer. Okay? Now that I have it in this form, it's like what we talked about last week. I have it's a quadratic, so I want to get it equal to 0, right? Subtract 2x from both sides. Add 1 to both sides. 0 equals x squared minus 6x plus 5. How many ways do we know how to solve a quadratic equation? 1,000. Okay, that's pretty close. 1,007 or 7. Oh yeah, that's probably probably a little closer, but that's okay. Okay. How do you want to factor? How do you want to solve this one? I told you the answer when I was asking the question. Sorry about that. I would factor. Some people might use a quadratic formula. We could graph it and see where it crosses the x-axis. Those are all ways that we know, right? So x minus 5 and x minus 1 equals 0. So x minus 5 equals 0. X minus 1 equals 0. So x is going to equal 5 and 1. Now, do they both work? Is it possible to get two answers and one of them works and one of them doesn't? Is it possible to get two answers and neither one of them work? Is it possible to get two answers and both of them work? Well, we'll just try it. How about that? Okay? 5. 2 times 5. 10 minus 1. Square root of 9. 3 plus 2 is 5. That one works. 1. 2 times 1. 2 minus 1. 1. Square root of 1. 1 plus 2 is 1. That one does not work. Okay? So here's what I want you to think about. What does the graph of a square root function look like? Do you remember? Yeah, it helps if you make the sound whoop like that. Okay? How many times is that graph going to cross the x-axis? Once. Okay? So just keep that in mind when you're working with this. We got two answers because we turned it into a quadratic, didn't we? So we should get two answers when we're dealing with a quadratic. But the original problem is it's a square root function. And it looks like this. It's only going to cross the x-axis one time. Okay? Any questions about that? How comfortable do you feel with solving equations with with radicals? Pretty good? Okay. Next one is solving equations with rational exponents. Do you remember rational exponents? What does rational mean? A fraction. So if you have rational exponents, it just means exponents that are fractions, right? So 3x to the 3/4 power minus 6 equals 0. Now some of you might have this, or at least recognize this. Do you recognize this? It's a foldable we made. Yeah. He made me cry last year because he was like, oh no, I already know how to do this. I still have my foldable. And I'm like, oh, I'm so proud of you. Yeah. So if you have this, you can use it, especially on this unit. It's fine with me. Okay, it reminds us of all of our exponent properties. Remember we even talked about at the time that rational exponents follow the same rules as just whole number exponents. Okay. If you don't remember, you can come and borrow my foldable. As long as you give it back. Okay. So what do you think we would do to start solving this equation right here? Add 6. Good. 3x to the 3/4 power equals 6. And now, divide by 3. Okay. X to the 3/4 power equals 2. How do I get rid of this exponent? I do the reciprocal, right? Multiply both exponents by the reciprocal of this exponent. Now I'm not multiplying the number 2 by 4/3. I'm multiplying the power, which is 1, by 4/3. Does that make sense? Okay. So x is going to equal 2 to the 4/3 power. Now that's not something I know off the top of my head. If I needed, God bless you, if I needed a decimal answer, I could certainly put that in my calculator and get a decimal answer. But remember, the thing I want you to remember is that the top is the power and the bottom is the root. So another way we could write this is the cube root of 2 to the 4th power, or the cube root of 16. Those mean the same things. Okay? Do I need to do any more of those? Are you feeling comfortable with those, or should I do another? Another? Okay, I will. What if I had x to the 2/3 power minus 3/4 equals negative 1/2? Now, some of you just freaked out because not only do I have fractions in the exponent, now I have fractions in the problem. Just calm down. You're fine. Okay? What do I do first? Add 3/4. Here's where the x is, so I want to isolate the x. So let's add 3/4 to both sides. Okay? Now, isn't 1/2 the same as 2/4? Okay? So basically what I have is a negative 2/4 and a positive 3/4. So 1/4. Okay? Now how do I get rid of that exponent? So I raise both sides to the reciprocal of that power. On this side I just get x. But in this problem it's a little bit different, right? Because the top is the power and the bottom is the root. Do we know the square root of 1/4? Isn't it just 1/2? Right? Square root the top, square root the bottom. Isn't it 1/2? Well, what's 1/2 to the 3rd power? 8. 1/8. Okay? So we actually got a nice pretty number there. And the only difference we have to think about, we have to make sure, is that we have a plus and minus there, because I did actually take a square root. So I can't just assume the positive always. I have to keep in mind that there might be another possibility there. Okay? Any questions about that? Feeling any better about rational exponents? Good. The next problem on our list, or our next objective, excuse me, is solving equations that are in quadratic form. Well, let me make sure you know what that means before I go do a whole bunch of examples, because I think if you see what I mean, we may have to do one or two, but the rest of them are going to be pretty cinchy. Okay? So something in quadratic form would be x to the fourth minus 8x squared minus 9 equals 0. Do you see why it's called a problem that's in quadratic form? Boy, that looks like a trinomial that I could just factor, right? The only problem is that's not a squared and that's not a x by itself, right? But it is an x to the fourth and an x squared. And if I multiply this term right here, x squared times x squared, don't I get x to the fourth? So it is a problem that I could factor. Okay? What would it be? Multiplies to be negative 9 and adds to be negative 8? Negative 9 and 1. So x squared minus 9 and x squared plus 1. You okay with that? If I set each one of these equal to 0, I would get x squared minus 9 equals 0 and x squared plus 1 equals 0. Now, some of you might have noticed that that's a difference of squared and you want to factor again, right? And if it was asking you to just factor, we would go to x plus 3x minus 3, right? But all it wants us to do is solve. And the nice thing about this is when I add 9 to both sides, I get x squared equals 9. And when I square root both sides, I'm going to get plus or minus 3, just like I would have if I would have factored it. Here I would have to subtract 1 from both sides. X squared equals negative 1. When I take the square root of both sides here, x equals plus or minus I. So something that you might see in your homework is doing this problem slightly different way. Okay? Here's what I mean. In the textbook and on the examples that they give you on the computer, they have you doing this with the u substitution. Now, a u substitution is something that I used a lot in my graduate level math classes, especially in my calculus, upper level calculus classes, and in several of the other classes that I took. Okay, u substitution means I'm going to substitute u for something. And I have to decide what that is at the beginning. Okay? In this particular problem, what I want is something squared and something, and then the constant, because that's a quadratic. That's what I'm used to solving, right? So I could say from the very beginning, x squared is going to equal u. And anywhere there's an x squared, I'm going to substitute a u. Well, that means this term right here would be u squared, right? And then this term would be minus 8u. And then minus 9 equals 0. Well, that's a quadratic, isn't it? And I could solve that by saying u minus 9 and u plus 1, just like I kind of did right here, equals 0. So u equals 9 and u equals negative 1. Yes, sir? So I start with x squared equals u. That's my u substitution. I rewrite my original problem. Instead of writing a x squared, I write a u. Since this is x to the fourth, that would be the same as u squared. Does that make sense? Okay. So from here, I just solve it like I know how, and I get u equals 9 and u equals negative 1. Now I have to go back and unsubstitute my u. Okay? U equals x squared, so I replace the u with the x squared and continue solving for x. So I just square root both sides and get x equals plus or minus 3. Square root both sides here and get x equals plus or minus I. And in fact, I got the same thing. Some people are more comfortable doing this. Some people are more comfortable doing a u substitution. So I just wanted to make sure that you could see both ways. Yeah, it makes it visually a little simpler. You just have to remember to go back. After you solve for u, you have to remember to go back and unsubstitute for u, basically. Okay? So that's an example of an equation that is in quadratic form. So you know how to do it because you know how to do quadratics. It's just not exactly quadratic, it's just quadratic in form. Okay? Absolute value equations. We spent quite a while in Algebra 2 on absolute value equations, but in all fairness, it was at the very beginning of the school year. So I'd like to go back over that with you. Okay? So, for example, if we have absolute value of 2x minus 1 equals 5, our typical steps when we solve absolute value problems, our first step is to isolate the absolute value. Okay? Our first step is to isolate the absolute value. After we isolate the absolute value, then we write two parts. We write a positive part and a negative part. What part can change signs? The part that's inside the absolute value or the part that's outside the absolute value? Inside, right? So we have the inside part, the inside part being positive. And what I mean by being positive is I just take whatever's in there and I just write it. Okay? And then the inside part being negative looks like that. Okay with that? Well, now I just solved these just like I normally would. 2x equals 6. So x equals 3. Here we could either distribute the negative throughout the problem, or we could divide it by -1 from the beginning to still have 2x minus 1 equals -5. That's a minus. Adding 1 to both sides gives me 2x equals -4. So when I divide by 2, I get x equals -2. Right here, I divided both sides by a negative to get rid of that negative sign right there. Or, let me show you this though real quick. I could distribute this right here and get -2x plus 1 equals 5. If I did it that way, I would get -2x equals 4. So x equals -2. I still get the same answer. It's just how you think about the problem. Whether you want to get rid of the negative sign first or whether you want to distribute it. How are you more comfortable doing it? Okay? So my two problems, or my two answers, I think, are 3 and -2. So I messed up my list over here because I only did the first two. The next one is solve. The next one is check. And the next one is graph. And this really depends on what you're being asked for. If the graph is part of the answer that you have to choose from, then definitely look at the graph. The graph for us would typically just look something like this. Done, done, done. Except I wrote the 2 on the wrong side of the 0, so that's actually wrong. So I will fix it real quick. 0, -2, and +3. -2, +3. Is that better? Yes. If it asks for the graph. We did a lot of graphing of it in Algebra 2 because then the next thing we did in Algebra 2 was absolute value inequalities, and that's a big deal. The graph is a big deal in inequalities, and we're actually going to do that next time we meet. Okay, we'll talk about absolute value inequalities the next time we meet. Okay, but absolute value equations. Isolate the absolute value. Do you see how this absolute value is isolated? Sometimes people want to add 1 right here to try to get to the x. But do you see how the absolute value is isolated right now? There's nothing being added, subtracted. There's nothing being multiplied or divided. The actual absolute value is isolated. Okay? Does that make sense? So after we isolate it, we write it into two parts. whatever's inside being exactly what it was, whatever's inside the opposite of what it was. We solve each one of those. We check each one of those. 2 times 3 is 6, minus 1 is 5. The absolute value of 5 is 5. 2 times negative 2 is negative 4. Negative 4 minus 5 is negative 5. But the absolute value of negative 5 is equal to 5. Okay? Let me give you some scenarios really quickly. Anytime you're doing absolute value, when we do absolute value of anything, I'll just say x plus 5 equals a negative 4. That should be, you should have alarm bells in your head. Okay? Listen to your midi-chlorians here. Right? Listen to them. Because is a positive number ever going to equal a negative number? If your absolute value is completely isolated and it equals a negative number, that's no solution. We can actually complete this problem and we will get 2 answers, but when you plug them back in, they will not work. Because never will I plug in a number here and get an answer that equals a negative number on the outside. Does that make sense? Okay, so just be aware of that. But that's solving equations using absolute value. Okay, and the last one of our objectives for today is solving problems modeled by equations. Like I said earlier, that's just word problems. Can you come up with a word problem, can you come up with an equation if you're given a word problem about any of these topics? And I think you can. That's something we worked really hard on in Algebra 2. Okay, but if you do have an issue, you know you can ask and we can work through it together. Okay, any questions about any of that?